So today, first of all, I'm going to start with inheritance mappings. We'll see inheritance mappings here. You know, when you have inheritance relationships here, how you're going to map the inheritance relationships? That is a question. For this, let's consider an example. In that online shopping site, you see we are implementing the same case study. Let's say you have users of two different types, buyer and seller. You have two different types of users. Now your task here is, let's say, you're supposed to define Java classes here for this users here. We need to define Java classes appropriately. So define a Java class for the buyer objects and a seller class for seller objects. Now you will find that here there will be few common fields between the buyers and sellers, right? So that common fields will add them to the user class. Like you see, user ID, user name will be there, phone, gender. You can have several common fields, first name, last name, whatever it is. So that's the reason why what we'll do here, we'll define a user class and we'll add the common fields and methods in the user class, and we'll make this buyer and seller extend the user class here, right? That is what we'll do. So already I've got those classes. I'll show you people. So just check this class. Don't worry about that mappings. See, we got a class called as user. You see, we got the fields like user ID, first name, last name, and user has got an address. So we'll associate this. Sorry. So next, we got the buyer class. You see, buyer class, it extends user class, and to the buyers you'll have bits associated. To the buyers you got bits associated. You see, let's say buyer will have some one additional property here. Buyer has got one additional property, that is favorite category. Only for buyers you'll have it. That's the reason why I see that variable is declared only here. Okay. Yes. Next, we got seller class. Seller extends user. You see, seller extends user. Yes. And you see, to the seller items are associated. Only to the seller, these items are associated. Sorry. So now you see, for the seller, you have credit balance. So what is this credit balance? Here you will find that the credit balance, this property, generally it represents that amount the company owes to that seller. Why the company owes to the seller here? Because seller will place items for sale, right? Seller will place items for sale. Yes. Okay. Because the seller places the items for sale, that item, whenever that item is sold out, that amount will be paid to the company, online company, right? So this amount, you'll find that company should pay to the company should pay to the seller. That is the credit balance. The company, whatever the amount the company owes to the seller, you'll find that that is the credit balance here. Okay, that is nothing but the credit balance. Yes. Okay. Now we have these three classes: user, buyer, and seller. We got these three classes: user, buyer, and the seller here. Okay. So this is the hierarchy now. So you see few fields, you'll find that they are declared in the few fields are declared in the superclass, user class, and few fields are declared in the subclass. Okay, few fields are declared in the superclass, that is user class, and few fields are declared in the subclasses like buyer and seller. Now how to map this inheritance hierarchy, how to map this inheritance hierarchy to the tables or database here. What you're going to do? Yes. How will you map this inheritance hierarchy here? Yes. Just a second. Yes. So how will you map this hierarchy, inheritance hierarchy which you got here in the database server? So the database server, will it support inheritance concepts? Does the database server support that inheritance? No, right? Database won't support inheritance. So can you people tell me how you're going to map this classes here? How will you map this classes to the tables in the database server? How are you going to map these classes to the tables in the database server? Don't worry whether it is right or wrong. Just try to answer this question. That's it. Okay. So I'll tell you people. You know what? Here you will find that we got three different strategies. Inheritance mapping strategies are there, which are supported by Hibernate. So they are supported by Hibernate, I can say. Yes. Okay. What are they? First of all, table per class hierarchy, or we say single table strategy. Next is table per subclass. The last one is join table strategy. Okay. So These are the three different strategies which you got. Which are supported by Hibernate. Hibernate helps us with the strategies here to Hibernate will help us to work with this inheritance mappings using the strategies. Okay, let's see. Okay, let's see. Now we are going to work with the strategies. First of all, let me add those classes to our project here. Just a minute, let this ID load. I'm sorry. Okay, so let me copy this classes. Already have this user, buyer and seller classes. So without wasting our time, so just we'll copy them. So they're simple Java classes, nothing more than that. Now we'll see how to map these classes here to the database. So first of all, to map the inheritance hierarchy to the table in the database, we'll follow the first approach. Table per class hierarchy. Now in the hierarchy, how many classes we have in our example? When I say hierarchy here, what are all the classes which are involved? Can you people tell me? In the hierarchy, what are all the classes which are involved? Just a second. Yes, tell me. When I say class hierarchy, what does it means? Yes, class hierarchy means when I say class hierarchy, yes, what it includes? All the three classes, the complete class hierarchy, user, buyer and seller. That's right. So all the three classes will be included. So, you know what? This strategy, the name itself indicates. For the complete hierarchy, you'll have only one table. All the three classes will be mapped to a single table. All the three classes will be mapped to a single table here. Yes. All the three classes are mapped to a single table. That means, this indicates that the user and the seller and the buyer records will be added to the same table. The user and the seller records will be added to the same table here. Yes. User and seller records will be added to the same table. Yeah. So, but sorry, not user. Buyer and seller records will be added to the same table. You see, if the buyer and seller records, if they are added to the same table, will there be an issue? Do you think will there be an issue? If the buyer records and seller records, if they are added to the same table, will there be any issue? Yeah, there can be an issue. I'll tell you people why we'll have an issue. Why there will be an issue, let's see. You can have an issue because here both the records are added to the same table, right? If both the records are added to the same table, in that case, it will be difficult to differentiate the buyer and seller records. Sometimes it will be difficult to differentiate the buyer and seller records. That will be the issue. So because both the records are added to the same table. So how will you differentiate the buyer and seller records? Can you people tell me any solution for this issue? Can you people tell me any solution for this issue? Uh, Not join. We will have only one table, right? We got just one table here. Yes. You know, in this case, what we can do is we have only one table. In this case, what you can do is you can use a common column. You can use a common column in this case. I'll show you people. A column. Sorry, you can use a column. Column. You can say, which will help us to distinguish the user and the buyer records. It is going to help us to distinguish the user and buyer records. I guess I don't have the table here as of now. What we'll do is we'll add a column. That column will help us to distinguish buyer and seller records. You know, That column will hold that user type, whether it is buyer or seller. That user type will store it in that column. If it is buyer, let's say that column name will be buyer. Column value will be buyer. If it is seller, that column value will be seller. This way. Okay. So now we have to map those details. Let's try to do that. First of all, we got this user class, you see. Now we have to specify the inheritance strategy which we want to use. Strategy equal to table for class. So if you want to use a table for class hierarchy, this is how you will configure the details. Okay. This is how you will configure the details. Next, you see, we'll configure a table here for the superclass. Sorry. Okay. Now you see we have configured a table. Now you see the fields will be mapped to the columns. The fields are actually mapped to the columns. Okay, this is same. Now you see this user has got address. We got one-to-one association here. Okay, it's all simple and straightforward. But as I told you, people, to differentiate the records, will have one column. So we call it as a discriminator column. Discriminator column. Discriminator column. So that column on details we have to configure it here. So at the rate discriminator column. So that column name you have to specify. It can be anything you wish. I'll call it as user type. And that column should be what type. You have to also specify that. String. Okay. This way you'll specify that column details. Discriminator column details here. Yes. So next you got buyer class subclasses. So for buyer classes will not map any table. There won't be any table for the subclass. Only for the superclass. Only there is one table for whole complete class hierarchy, right? What you will do is, but whenever the buyer record is added to the database, so what value should be added to that discriminator column? That value we need to specify here. Discriminator value. So what should be that value here? Yes. It should be buyer. That value should be buyer. Yes. Discriminator value should be buyer. Yes. Okay. Similarly, you got seller. That's it. We don't need to do anything here additionally. If you got any fields, you'll map them to the columns. You see now buyer is associated to bits, right? Buyer will be placing the bits. So what are all the bits the buyer has placed? So that bit objects will be associated to this buyer. So one to many association here. This association you already know. So nothing special about it. So only thing is here we'll add this matter value annotation. Even the seller class will not be mapped to any table. And here, whenever the seller record is added, so we need to specify what value you want the seller. That's it. Okay. That's it. So we are done with this mappings. Now what's next? We'll configure the entity class details here in the configuration file. User, buyer, and seller. User, buyer, and seller. That's it. Now what I want to do is here, I would like to create a separate schema for this. I'm creating a separate schema. In that schema, uh, you know, I'll call that schema as eShop. Schema means, it's a collection of tables in the database server. We will create a separate schema eShop. As of now, in that schema, we'll not have any tables. Okay, I got a schema here already, but I'll drop it. I'll create a schema here with the name eShop. eShop. So now we got a new schema. There are no tables in the schema now. It's a fresh schema. You see, there's nothing here. Now what to do? Are we supposed to create these tables like user, buyer, and seller? Sorry. Are we supposed to create the table here? You can create it manually if you want. But Hibernate comes with a tool called as HBM to DDL. Hibernate comes with a tool called as HBM to DDL. So you can just simply specify this. Create. What this HBM to DDL does, it will generate a table if it is not available. Okay. So it creates a new table here for us. That is what this HBM to DDL tool does. It creates a table, I can say. So we are not creating the table manually. Now this tool called as HBM to DDL will create the table. Okay. Hope everyone got it. So you have to configure this tool this way using the property hibernate.hbm to ddl.auto. But how this tool will know the table details, what table it is supposed to create, how the tool will know? What do people think? How the tool will know what is the table, what table it is supposed to create? Yes, from the mappings which we did using annotation. You see, we are mapping using these annotations. We are trying to map this class to the table, right? So we have provided the complete details about the table. So the tool will use that table itself. Tool is going to use that table itself. So sorry, tool is going to use that table details which are configured here in the annotation. So now let's do one thing. The table is created, will be created freshly, right? So we'll try to add some record, add a record, at least one record. Just a minute. Okay. You see, we got buyer, seller, and user tables. Sorry, classes. And along with that, you see, buyer is associated to bits. Bits is associated to table item, right? And buyer is associated to address. So we have all this details. Just a second. I'll explain this. I got the code to create this objects. I'm just adding parameterized constructors so that we can initialize those objects. So you see, to the buyer, bits are associated, right? And to both the users and both the buyers and sellers, you got address. So that we have added to the user class here. Okay. And seller is associated to items. Yes. Just a minute. I'll delete one class here called as customer. Just a minute. So instead of customer, using user class. Okay. Now let's see this. All of you just go through this code once. What we are doing, we are creating a buyer object. We are creating bid objects. Okay, slowly go through this code. I'll give you a couple of minutes. I'll mute myself. Just go through this code, what we are doing here. Yeah, I'm sorry. So hope you people saw this code. So what we are doing, basically we are creating objects here and we are associating them. First we are creating buyer object and then bid objects, then item objects. Now bits are associated to the items and we are adding the bits to the collection, and that collection of bits we are associating to the buyer. At last, the address is also associated to the buyer. That's it. So this way all the objects are associated. And then we are adding the buyer. Then we are adding the buyer. So if we add the buyer, what about the associated objects? Even they will be associated to the to this objects here, to the buyer. Sorry, we are adding bid object, right? Sorry, buyer object. What happens to the associated objects like bid, item objects, and address objects? Will they be added to the database server by default? If you add buyer object, even the associated objects, will they be added by default? What do you people think? Yeah. What do you people think? So we are adding bid buyers, right? So if we add buyers, so the associated object like address, bits, items, will they be added to the database server? No. By default, it won't happen. So this is where you got cascading, as I told you people. You see, we need to enable this cascading. If you specify this cascading, then what happens? The associated objects will be added. So in the bit class also you do the same. So that the bits items are associated, right? So in the in the bit class also you enable this cascading here. Cascade type dot all. And see in the user class also, okay, already it is specified. So user is associated to address. See on top of it we have specified this cascade type dot all. So this way we'll specify the details, cascading details. So cascading means, you see, if we add the buyer, now you see to the buyer bits are associated. So whatever the operation we have performed on the buyer, if we are trying to add the buyer records, even the associated bits will be added to the database. So the same will be the case here for the sellers and the bits also. So if you add bits, the associated item objects also will be added. So we have enabled cascade. That is what happens. Okay. So even the tables are not existing. So the tool will be creating them as I told you people. So let's run this code. Okay, good. So lot of queries are generated here. So first of all, you see that HBM to DDL tool, what it does is it will try to drop the tables if there are any existing tables. And then it is creating the tables here. And then it will add that constraints, foreign key and primary key constraints. And then it will fetch the record. It will add the records. Yes. So now let's see. Refresh this eShop schema. Now you see in the eShop schema here, we have this tables. So in the eShop schema, we got the tables here. Okay. Yes. So what are the tables? These are all the tables which you got. First, let's see the buyer. We got the buyer table. User ID, first name, last name. Sorry, not the buyer. Why it is creating buyer? Just a second. What I've specified here, I'm sorry. Let me check once. Table per class. Oh, sorry. Sorry. The strategy, I've specified it wrong. So actually the strategy name is single table strategy, right? Sorry. It should be single table strategy, not table per class. I'm sorry. Change it. Single table. The hierarchy name, the strategy name should be single table here. Okay. Please specify as single table. So let me drop the schema. I don't want to drop each table. Yes. Okay. Now let's see whether it creates a schema also. Okay. Let's see whether it creates a schema. If not, we have to create. I'm running this code again. Sorry, I specified that strategy name wrong. No, it's not creating the schema. So schema should be existing by default. Okay. Let's create the schema. So the schema name is eShop. Now let's run this code. Okay, it did that. Now you open the database, refresh the C# schema. Here you got the tables. Now you should see a user table here, e-user. You see in the e-user table, you got user type, buyer. User type column is there, which will help us to differentiate the records. Then you got user ID, first name, last name, category, if category is for this buyers itself. CR balance, this column value is null because it is seller column. So there won't be any value associated. The last column is a foreign key column which is associated to the address. So you got the address here. Address is another table. And then you see this buyer ID is 101, right? So let's go to the bid table. So in the bid table, you'll have two bits associated to this buyer. You see bid ID, buyer bid ID. This is the foreign key column which refers to the primary key of the buyer table. Yes. You see this way all these tables are associated here. So hope you people got it. Is it clear for you people? Okay, good. So hope everyone got it. So this is one of the strategies. Okay, all of you, please excuse me. Give me a couple of minutes, please. Give me a few minutes. I'll be back in a few minutes. Give me a few minutes. Sorry. Okay, now let's move on to the second or next strategy here. Move on to the next strategy. Next strategy is table per class hierarchy. Table per class, that's it. Or you can say table per concrete class, subclass. Table per subclass also. That means the name itself indicates only for the subclasses you'll have tables. Only for the subclasses you'll have tables. So you see in our example, we got how many subclasses? Seller, buyer, and user hierarchy. In this hierarchy, you got two subclasses. That means you'll have only two tables. You'll have only two tables. One table for buyer, one table for seller. One table for buyer, one table for seller. Okay. Here, but how this user class fields will be mapped to the table? How the user class fields will be mapped to the table? You will find that the user class fields they'll be mapped to both the tables, seller table and buyer table, both the subclass tables. So you'll find that this fields, the columns for these fields, user class fields will be in both the tables. Okay, in the buyer table, you'll have that user class fields in the seller also. Yeah. So first of all, let's see how to configure the strategy. Inheritance type dot single table strategy. Specify the strategy name as single table. Now we'll not specify the discriminator column details. There won't be any discriminator column because the records are stored separately in separate tables itself. Right? Yes. So for the super class, for the user class, we'll not have any table now. So I'll remove this. Okay. But before that, I'm sorry. Let me do one thing. Before I change this details, so I'll export this project so that I'll add it to the Dropbox folder. You can go through it just a minute. Let me export it. Okay, I'll give you that. Fine. Now let's modify this. Inheritance type is table per class. There won't be any discriminator column here. Remove this. There won't be any table also for the super class. Normally, you'll map this fields here. That's it. You're going to map this fields. That's it. Next, you got the buyer class, right? For this class, you need to add a table. Name equal to buyer. Okay. And here, what else we need to do? Nothing. That's it. Just one change. Add the table. Map this class to the table. Map this class to the table. That's all you need to do here. Okay. Next, we'll remove the discriminator value annotation also at that. Here also will not have for the seller class also. There won't be any discriminator value. Instead, we need to map this class to the table. This way. That's it. Okay. That's all you need to do. Now let's do one thing. Now you see the table structures are going to change, right? I'll drop the schema completely. So I'll create it again. And I can delete the tables one by one, but it would take more time. So I'm not doing it. Sometimes even this HBM to DLT will not be able to drop the tables properly because of constraints and all. Yes. So in the training, I will do this. Generally, we may not delete the schema this way, but in the training, quickly I have to do this. So let's run this code. You see, the records are added successfully. So let's refresh the schemas. You got the tables, you see, seller and buyer. You open the buyer table. You see the columns here, user ID, first name, last name. This is the foreign key column and the categories. Yep. So similarly, you got a table called a seller. You see the seller table. These are the columns in the seller table. So any questions in this regard, please let me know. Any questions in this regard? No, right? Okay, fine. Let me export this project also. This is table for subclass strategy, a table for class strategy is it. As a name project, table for class. I've exported that project also. Next, what we need to do is here, we need to go through the third strategy, join the table strategy. Join the table strategy. Yes. So can you people talk about join table strategy? Any idea? Any idea about join table strategy? Can you just tell me? Okay, I'll tell you people. You know, you'll find that according to this strategy, according to this strategy, for each class here in the hierarchy, for each class in the hierarchy, you'll have a table. For each class in hierarchy, you'll have table. That means for the user class, you'll have a table. For the buyer class, you'll have a table. For the seller class also, you'll have a table. Okay. But if you have a table for each class, that means your records, sorry, whenever we add a record, for suppose if you add a buyer record, so that buyer record will be partially added to the user table and partially to the buyer table, because the fields of the buyer class are mapped to both the tables, right? The record will be partially added to the buyer table and partially added to the user table. So the same is the case for seller also. If you try to add a seller, the seller record is partially added to the seller table and to the user table also. Yes. It is partially added to the seller table as well as to the user table. Yes. Okay. That is what happens. So those two tables now, the buyer and the user tables, seller and the user table will be mapped. Okay. I'm sorry. I'm sorry. So how they will be mapped, that is what you need to understand. So what happens here, you'll have a table for user, you'll have a table for buyer and seller. So few fields will be mapped to the user class will be mapped, user class fields will be mapped to the user table. Buyer class fields, we got one additional field which will be mapped to the buyer table and seller table also. Now the question is how this tables will be associated. So we'll find that here we need to add a column, primary key column to the buyer table, which acts as both primary key and foreign key also. That means this table column, buyer user ID, it refers to the primary key of the user table. It will be referring to the primary key of the user table. Similarly, you'll have a primary key here, which also acts as a foreign key. It also acts as a foreign key. Okay, it also acts as a foreign key. Okay, so we'll try to work with this. Let's try to map this classes. So the strategy, first of all, change it to join table strategy. And here you won't make any changes to the superclass. Okay. For the superclass, we'll have a table now. So map the superclass to the table. Name equal to user. Say user. Something. You see, the buyer class will be mapped to a table. Now in the buyer class, we should have a additional column which acts as both primary key and foreign key. So to add that column, we use this annotation, primary key join column. What is that column name? Your wish, it can be anything, but I'll give a meaningful name, say buyer user ID. You see the annotation name itself indicates that means it acts as both primary key as well as join column. Join column means foreign key column itself, if people know that. Join column means foreign key column itself, right? Yes. Similarly, we are going to do the same here for the seller also. On top of seller also, seller class also, we do the same. Primary key, join column, name equal to buyer, sorry, seller, user, ID. That's, that's it. So this is what we are going to do here. Okay. So let's delete the schema and add it again. So let me run this code. Okay. So let's refresh the schema. Now you will find that here you got a user table. You see we are adding a buyer record. A buyer record is added here in the user table and partially in the buyer table also. Yeah, I'm sorry. Okay. Now you see this column buyer user ID is the primary key as well as a foreign key here. It's a primary key as well as a foreign key. Yes. Okay. So this is how the join table strategy works. So is it clear for you people? Join table strategy. So any questions? Okay, good. So what which strategy is better here? So what do you people think? Which strategy is better out of this three strategies which we saw now? Which strategy is better? What do you people think? Yes. Just do any guess otherwise. Just do a guess which strategy is better. No comments. Okay. You know, here I can say that the last strategy, the joint table strategy is better. Joint table strategy is going to be better here. Yes. So what do people think the strategy is better here? Yes. So why do people think this strategy is better? Joint table strategy is better because you know in the first strategy the two records are added to the same table, right? In the first strategy, you'll find that both the records are added to the same table. There, you see, there is one issue with that strategy. I can say, what is it? You'll find that here, whenever you're adding buyer records, whenever you're trying to add buyer record, the seller records columns will be null. The seller record columns will be null. Okay, seller record columns will be null. And whenever you're adding buyer records, you have whenever you're adding seller records, the columns associated to the buyers will be null. Columns associated to the buyer will be null. That means we cannot always add that non-null constraint over there to that records, to that columns. Okay. Yes. Always have that null reference issues. So when you add a buyer record, the columns associated to the seller will be null. If you are adding seller records, the column associated to the buyer will be null always. You cannot add that non-null constraint and all in that case. Yeah, that is the issue with the first adding. Even if you have if you have so many columns uh, for both buyers and sellers, then it will be difficult. If you have so many columns, then it is a difficult strategy here. Okay, to implement, I can say. Yes. Yes. Next, we got the second strategy. Now, do you see any issue with the second strategy? Yes. Do you see any issue with the second strategy? Any drawback? No? Okay. Hope you are able to hear me, right? Just want to confirm. Okay, good. So, fine. You see, for the second strategy which you saw, I can say that see that user class fields, they are redundant. You have to add them to both the tables. You have to add them to both the tables, right? Okay, you have to add them to both the tables. So they are redundant. That is what I can say. Yes. Sorry. So the last one, I can say that it's the best strategy here. Last one, the best strategy. Join table strategy. Why you got? Why I'm saying it's the best strategy? Can you people tell me? Yes. Why it's the best strategy? because you see here there is no scope for redundancy here, and you know there won't be any duplications and all, and especially this strategy, you'll find that it is according to the normal forms. It is normalized. This is the most normalized I can say. Okay, this is the most normalized here. Yes. You see what is normalization once you check that. Okay. So this is about your strategies. So inheritance strategies here. So with this, now we have implemented that domain model, online shop model completely, right? So hope you got everything here. So is it clear for you people, all of you? Okay. So Hibernate is helping us to easily map this inheritance relationships to the tables in the database. Hibernate is helping us in this regard. Yes. In JDBC, do we have any such support for inheritance mappings? In JDBC, is there any support for inheritance mappings here? No, you won't find any support for inheritance mapping. Now, you see, you almost understood all the features of your Hibernate. Now, how this is going to be advantage Hibernate, how the features of Hibernate, yes, will help us in filling up that gap between the Java applications and the database server here. Yes. So now we are left over with fetching strategies, like we got lazy loading, eager loading and all. We have transaction management, and the last thing is we need to see caching, first level cache and second level cache. So these are the leftover topics for us. And the entity object lifecycle, entity object lifecycle. So these are all not big concepts. the small concepts itself. Yes. Entity object lifecycle. Okay. So fetching strategies and entity object lifecycle one class is enough. Transaction management caching one class. I have a request. So will you people be able to attend the class today evening, a special class today evening? I will talk about entity object lifecycle and fetching strategies. Today evening at what time? 8 p.m. Central Time. Is it possible for you people? 8 p.m. Central Time. It will be for 1.5 hour. So where I'll talk about entity object lifecycle and the other topic is fetching strategies. Yes, please confirm that because I will be cancelling another session for you people. Okay, I got another class, but I want to spend some time with you people, so that's the reason why. So I have to cancel another class for you people. So that just hope you people will be available, right? Yes. I want yes or no from everyone, whatever it is. Okay, because after canceling the other session, if I take a class for you people, if I don't see anyone, then it will be you know a disaster for me. Yes. Okay. So I'm assuming that hope everyone will be attending this class. Yes. I got only a couple of answers. Yes, that's it. What about others? Okay. So just try to attend this class, and tomorrow morning again we will meet at our class at our regular time. So today evening we got a class at 8 p.m. Central Time. It will be for 1.5 hour. Okay, that's it. 8 p.m. to 9:30 p.m. your time. So we'll have a class. So that's all for today then. So let's meet it today evening.